And we are live. Good. Okay, so let's take a look at what you have. So first of all, today's date, September 1, 9/1/2021, okay? What we're going to be doing today is translations and transformations. I didn't do my notes very well. It's not very avid. It's not very good avid notes, but I'm working on it, okay? To translate means to move. Scoot it over a little bit. To move. And a transformation, I know you guys got to go back and remember. Remember that movie? What was it called? Was it Transformers? So what do Transformers do? They change their shape, right? So we'll change, so transformation is to change shape. Okay, it's the same thing, right? So translation is just to move. Transformation is to change shape, okay? So let's do that. So in example 1, it says given f x equals absolute value of x. So if you're not sure what that graph looks like, and hopefully you're figuring that out, well, we have that in our notes, right? If I take a look, you know, there it is, right? So it looks like that. It's the v. There's my absolute value of x. So I know that the parent function, I'll put in green, looks like that. Okay, there's my parent function. This is a question. It's telling you how to move it, okay? It's telling you how to move it, okay? Okay, it's telling you, so we're going to take this graph and we're going to move it to the left, opposite, right? To the left, 3, and down 2, opposite the inside, right? So this is a translation. It's not going to change its shape. It's just going to move it. It does not change its shape. So let's go 1, 2, 3, 1, 2. And there it is. There's our translation. This is a translation. What we did is we moved it. That's all we did. We didn't change it. It's not a transformation. We just moved it. Okay? Thumbs up? Okay, example 2. If I get going too fast, please tell me, okay? I don't want to go too fast for you, okay? Example 2, okay? Y equals, fx and y are the same thing. F of x and y are the same thing for us for right now. So if I have to graph this one, I'll put the parent function in green. Start at 0, up 1 over 1. It's a straight line. It's linear, right? So there's f of x right there. That's my parent function. And then I'm going to move it. It's a translation. I'm going to move it to the right 1 and up 5. So, you know, this graph's a straight line, so I'm just going to take the point at the origin. I'll go 1, 1, 2, 3, 4, 5. And there it is. Okay, how's that? That is also a translation. Okay, we didn't change the shape. Okay, example 3. Again, if you're not sure what these graphs look like, x squared, I think that's also in our journal. X squared's in there. If you're not sure, it's like, gosh, Mr. Davis, I forgot what that looks like. Well, there it is. Here's our x squared graph, right? It's a parabola. Okay, so I'm going to
put my parent function in. Okay, I'm going to go 0 squared. 1 squared is 1. 2 squared is 4. I'm going over 2. 2 squared is 4. 1, 2, 3, 4. 3 squared is 9, which is up here. Negative 1 squared is positive 1. Negative 2 squared is positive 4. Negative 3 squared is positive 9. It's way up here, okay? That's my parent function, okay? Now, we're going to change it, but this one's going to be a transformation because we're going to change its shape. So we're going to do a couple of things. Okay, so help me out. I would love your input. What do you think we're going to do? What do you think? Okay, take a stab at it. How are we going to change this graph from the directions here? What do you see? What do you see? What are we going to do? We're going to move it. How are we going to move it? What's this plus 4 mean? So we're going to go up 4, right? So we're going to go up 4. So let's go take the vertex. It's easier to move the vertex. You guys agree? Move the vertex. So I'm going to go up 1, 2, 3, 4. And then what's the negative mean right here? Yeah, it's going to be a reflection, right? So it's going to be upside down, or we're going to have a reflection over x-axis, or you guys are okay for right now, upside down. Upside down works for me. And what's the 2 mean? What's the 2 mean? What's the 2 going to do to this graph? Molly? Yes, so it's going to be a vertical, I'm going to stretch it, okay, vertical stretch of 2. So I'm going to do a vertical stretch of 2. Okay. So it went up 1. Now I'm going to go down 2, twice as much. It went up 4, twice as much. I'm going to go down 8, right? It went up 9, twice as much. I'm going to go down 18, which won't fit, right? So when I'll do that symmetrically, so I'll do it on both sides symmetrically. So let's do that. So we're going to go, instead of going down 1, we're going to go down 2, twice as much. It is symmetrical, so I'll put the other point there. Does that make sense? It's symmetrical, so I'll put a point here and a point here. Instead of going up 4, I'm going twice as much, but upside down. So I'm going to go 8. 1, 2, 3, 4, 5, 6, 7, 8. And it is symmetrical, so I'll put the other point here. And then the other one, I'm not going to be able to fit 18. It's going to go down 18. It's not going to fit, so I'm just going to put this in the best I can. There it is. Okay, how is that? Thumbs up? Okay, now, tell me when you're ready for me to turn the paper. I'll wait for you. Okay, square root of x. Well, let's take a look. I think that's in our notes also. Yeah, there's our square root, okay? There's our square root of x. It's going to look like that. Okay, so let's do that. Let's do our parent function first, okay? What's the square root of 0? Square root of 0 is? Square root of 0 is what? 0, right? Square root of 1 is what? So if I go over 1, the square root of 1 is 1, okay? I could do the square root of 2, but it's about a 1.41, blah, blah, blah. I could do the square root of 3, but it's a 1.73, blah, blah, blah. I mean, I could do that, right? But how about if I just jump to the square root of 4, okay? Square root of 4 is what? 2. So I'm going to go over 1, 2, 3, 4, and the square root of 4 is 2. Now, when I connect the dots, these numbers are there. Does that make sense? Those numbers are there. And then what's the, I'm going to go square root of 9. Does that make sense? Square root of 9 is what? Square root of 9 is 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3, and I'll graph it in, okay? All right, one more time. One more time. You know this. I'm going to say it again. Don't say it. Don't say it. Why is there no graph back here?
Emily, go ahead.
No,
No, you can't go that way. Why can't you go? Yeah.
Because you have a negative square root.
Nice job. Good job. You can't have a negative square root, right? You guys agree? So, unless you make the x's negative, which is kind of what we're going to do. This is going to be weird. So let's graph this. So now, if x's are negative, what's a negative and a negative? What's a negative with a negative? It's a negative with a negative. So now you can make them negative because when you make them negative, they become positive. So this graph is going to go this way. Because we learned in our notes that this is a reflection over the y-axis. Okay, good. So if I plug a negative number in, think about this. A negative with a negative makes a positive. And that's why you can plug in negatives, okay? All right, x cubed. I think that's in my notes also. If I take a look, x cubed. Yeah, it looks like that, right? Looks like that. There's my x cubed. Okay, so here's how to do this. Okay, I want everybody just to watch. Don't write this down yet. Watch. Okay, x cubed, okay? What is 0 cubed? What's 0 cubed? What's 0 times 0 times 0? Good. 1 cubed. What's 1 times 1 times 1? Don't say 3. What's 1 times 1 times 1? Don't say 3. Thank you. There are kids that would say 3. What is 2 times 2 times 2? Don't say 6. 8. Thank you. 2 times 2 is 4 times 2. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. What is negative 1 cubed? Negative 1 times negative 1 times negative 1. Negative 1. You're right. What is negative 2 cubed? Negative 2 times negative 2 times negative 2. Negative 8. Negative 2, 1, 2, 3, 4, 6, 7, 8. See, we're doing graphs in our head, which is awesome. We don't need a calculator, do we? Okay, so that's what the cubic function looks like, okay? We're going to move it. We're going to do a translation. We can do a translation. We're going to move it to the right 3. And we're going to go up 2. Okay, so I can grab any point, but I think the easiest point to grab is the one at the middle. Okay? And I'm going to move the whole thing, right? I'm going to move the whole thing, just go. Right? So I'm going to grab this. It's called an inflection point. Don't worry about that word yet. I'm going to take the inflection point and I'll move it 3, 2, and put my C graph there. Okay, does that make sense? Okay, 1, 2, 3, 4, 5, 6. And it looks something like that. Okay, last problem, when you guys are ready. Okay, cube root. So, cube root looks like this. Okay, I go to my notes, that's my cube root, it looks like this. So I'm going to put my parent function in first. Okay. I dropped my pen probably. All right, maybe let's have to use a different color. I can use a different color. Parent function in blue. All right, cube root. So, what is the cube root of 0? What's the cube root of 0? What times what makes 0? Good. What is the cube root of 1? What times what makes 1? Good. So then I'm going to go all the way to the cube root of 8. Because all the rest of the numbers are just ugly decimals. They really are. In fact, if I show you, I can do the... hold on. If I can do this real quickly. Math. Cube root of 2. Ugly number. Cube root of 3. Ugly number. So, I just have to get a general shape. So I'm going to go all the way to the cube root of 8. So what times what makes 8? 2, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and 2. And then we're going to do the negatives. So the cube root of negative 1, what times what times what makes negative 1? What times what times what makes negative 1? Good, so negative 1, and we'll do the cube root of negative 8 because it will be a whole number, so it'll be an integer. So what times what makes negative 8? Right, so we'll go back 8, 1, 2, 4, 5, 6, 7, 8, and negative 2, and here's my parent function. Okay, there's my parent function. So now we're going to do a translation. We're going to move it to the left, right? To the left, 2, and down 5. I'm going to take the whole graph, but for me it's just easier to take the inflection point and move it 2 and down 5. So we'll go 2, 1, 2, 1, 2, 3, 5, and it will look something like this. How's that? Okay. Thumbs up. Okay, I'd like to assign homework and give you guys time to work on it, okay? It will take graph paper. I want you to graph it, okay? So, and I will pass out graph paper if you need graph paper, but I want you to page 32. You do page 32, and I want you to do 1 through 9, all, and we'll do the extra is number 10. Okay, how's that? That's all I have. I gotta find the thing to stop the recording. There it is.